All right, redirect. Your program, believe it or not, has 3 file descriptors attached to it, aka inputs. Standard in, which we're just going to say for the sake of argument is keyboard input, just to make everything nice. Standard out, which is your monitor output, and then standard error, which is error to an output device. Okay. Did y'all do that with standard in? Well, you use cin actually, right? So cin is standard in, c out is standard out, and then you use c error or sir. It's a standard error, and those are different output streams. This is important because while you have one going in, you have 2 separate coming out. And by the way, you can add more to your program if you want to, but in Linux and even in Windows, all your programs or your process is here. All right, what's the difference between a process and a program? I'm now curious if y'all know.
Is the program like the actual code and the process like how it's executed?
Ooh, that was great. So the program, wow, allergies. The program is your actual code, right? In general, I mean, we think of it as source code, but really what it is you take your source code and then it compiles down to a binary file. That's your program, the binary file. A process is a running instance of that program. So you can have multiple processes that are running your program, if that makes any sense, hopefully. Great. Good. So your program is the actual code. You don't run you run your program by creating a process, and then the process executes your code, or your program, is what's going on. All right. Now for a different meta question. We're in computer science. We have so I told you your process works like this. You have a box, contains your process, you have an arrow going into it and 2 arrows going out. What's the next thing we are going to do? And I just said you can create multiple processes from your program.
Again?
What's that?
Do it again?
Do it again. Where are we going to put the other one?
Afterwards, so
After.
standard out is the standard in the new one.
By the way, computer science, you got to get really good at drawing boxes and arrows, all right? Very important. Very important. Very important. Whoops. Yep. Let's take a box and connect it to the other box. All right. Perfect. This is called piping. We're sending an output of one program to another. So you might do an ls on LA on spot. Some people like to call it etc. Some pronounce it etc. Others call it etc. I'm going to call it etc. And then you take that output, you pipe it to more. And of course, you can keep continuing this on more and more and more on. Hey, what data structure does this look like?
Queue.
A queue, yes. Hey, look, another queue. Let me show you this in action. So if I were to do ls-al on /etc, notice that the output went beyond the screen. There is no way for me to have seen all the output that quickly. My eyes do not function that fast. So if I do clear ls-la, etc., pipe it to more, what that does is it literally takes the standard output of this program, of this process, and hooks it to the input of more. What more does is give you the output of standard in 1 page at a time. It's a very old program, but I'll show you in a bit why I'm using it. So there's the beginning of it. Notice down here we have the word more. I can't scroll up or down. Oh, I can. If I hit down, I go down a page, but I can't go up. So every time I hit down, I go down another page, down another page, down another page, down another page, and there we are. Okay. Got it? So in Linux and Unix, this has always been the case since its inception. The idea of piping the output of one program to another is just hooking them up this way. Actually, there's another program. It's called less. It's like more, except for now I can scroll down and I can scroll up. What does that mean? less is more. You gotta laugh at these horrible jokes, or it's gonna be a really long semester, okay, guys? All right. So we can also do IO redirect to files. By the way, we're gonna keep going on. My other favorite thing is to get rid of a process in Linux. You use the kill command. Yes, you literally kill the process. That is what you're doing. All right. Anyways, and it's called bash, right? Come on, guys. All right. So we're back up here. One thing we can do ls, pipe it to ls. The other thing we can do is we can take the output and pipe it directly to a file. Let me go first into my own basic usage. I'll call etc.out. Again, the extension is meaningless. I'll call it .out because it's the output of this ls. Then I can go in and I can look at it, etc.out. Hey, look, there it is. I can go edit it all I want and jump around. And then I'm back to my program. Okay, cool. Right, so we can cat. All right, so cat's another one. So cat etc.out. What did I just do? It printed it to the screen. What do you think tac does? Cat prints it to the screen in order. Tac.
Oh, from the bottom.
Yeah, it does it in reverse order. I know it's silly. That's just how that's how they did it. All right, enough of cat. All right, we got more, we got less, we cat, which is concatenate, we got tac. Well, how do we pronounce, cat is short for concatenate. What's tac short for? To tacnate? I don't know. Anyways, password, you want to change the password of a machine, you type in password without the OR. Why they drop the OR? I don't know, but they did. Man stands for manual pages, not a man. It is manual pages. So the point of man. Okay, man ls will give you the manual pages for a program. So like ls, it'll give you the listing for it. There are other programs. Oh, it says name ls, list directory, synopsis, aka how you use it, options file, descriptions of everything you want. -a does all, don't ignore. You can give all, it tells you everything there is. Well, not everything, but hopefully everything's. Author, copyright, see also. You hit Q when you're done to quit, page up and down to read it. GCC, which is our, whoops, there's no manual, no way. Whoa. Do I even have G++? Oh, I do. Huh, I wonder why there's no manual page. How about make? Oh, there's make. Okay, cool. We'll get to that. How about CP? All right, so that's for copying a file. So yes, for all of the programs we use, there should be a manual page. If not, you'll need to go and install it, which I haven't done yet on this machine. But all the basic ones for this lab do come standard installed. Info is supposed to be a more advanced version of man, but I never use it. Most programs have a -- help, so if you do ls, let me clear real quick, ls -- help. It will also do the help, but hey look, it was too much, so let's go pipe that to less, and now we can actually view it and read about it. Okay, any questions? Lastly, regex. All right, I do not have time to go through everything about regex. Have you all done regex, whichever way you like to pronounce it? Any of y'all used this before? You have a little bit star. Okay. So star or slat, as I was taught as a kid, stands for all possible combinations. So DES star or splat could be desktop description. Why is this useful? Well, if I do ls test star, well, let me go up here, sorry. ls test star, what files is it going to print out?
All the test files we've been creating so far.
Yeah, all the ones that start with test. So notice it did not print out etc.out. Let's see. Let me just I didn't create a good example here, so let me create one. The question mark, oh, by the way, the star means 0 or more. So it could be nothing or it could be any number of things. So it's 0 or more. The question mark means there is one exact unknown at this position. So DES question mark stands for desk, DES9, DSA, whatever. It would not, it would stand for desk as is up here. It could not stand for desktop because there's more than one character. The question mark means one exact character. So if I were to do ls test.txt question mark, you would get .2 and .3. You can have more than one question mark. So 2 question marks is actually going to be the same thing in this situation. So let me go and just give you an example. .2, we'll go test.txt -4. So here, while the single question mark would only be the .2, .3, the second question mark would include the dash because it could be another option there. All right. How are we doing? I'm just trying to give you the basics, probably what you're going to be using. Okay, you can combine this a lot. I'm going to only talk about this because it gets a little, well, let me go to probably your most common usage, ls star.ps. So all the files that end with .ps or .whatever, so forth and so on. That's very common usage. Not as common, cat, don't, question mark, go. 2 characters followed by GO. Or any number of characters with an A followed by any more characters with a B, and then after the B there is one more character. That's what that regex is saying. I'm not going to test you over that. I'm really just going to tell you about star and question mark because after that we don't have too much time for this. It does get a lot more involved. For example, the solid brackets means it's something in the quote. So ls-al, when you have M or S, means it will only last files that are moon or soon, because it's saying it has to have an M or an S right there. It can't have anything else, so you can't specify. You can also use a dash, so anything that starts with an A through P, so A, B, C, D, E, F, G, all the way up to P, works as well. Not testing on this, but just showing you that there's a lot more options to regex or regex, whichever you prefer to call it, than what I'm showing you here. Really, the most important thing are the top 2 up there. Star means everything. Question mark just means one exact. All right. Any questions on this? Nope. Great. User admin. All right, we're not going to do too much on this. Well, I lied. I don't want to go into the commands too much. User add, if you want to add a user to your program, use it. D displays the information, and G gives you the defaults. Ooh, AL etc skeleton. That is, ooh, they changed it. All right, so AL etc password contains your users and all your passwords. That's where it's located. So let me go display to the screen without the A or the L. All right, so, whoops. We have a user called root. This means that the password is hidden in a different file. Haha, you thought I'd give you my password. This is the user ID. Root, of course, is user 0. This is the group ID. Group 0 because he's root. He's called root. His home directory is root. And his default script is bash. All right, don't really need to know about that. Just showing you an idea of what's going on behind the scenes. You can also delete a user, change the password, modify a user to either add a group or whatnot. You can read more about those commands if you need to. Hopefully you won't for this class. CSH changes your default shell. Right now, it's bash, known as the born again shell. Because yes, there was BSH, which was the born shell. Then they improved it. So of course, we had to be like that. You can use a GUI. Groups. Y'all know about groups? I think they're still called groups in Windows. Groups establish a relationship among many users. All right, so every user has their user ID, and they can be a member of one or more groups. And the groups may have general permissions. So if you want to have only certain users have access to the CD-ROM drive, to a Blu-ray drive, you can create a group and make it so only the group has access, and then assign users to that group one at a time. And you can go through and change this as well. I'm only telling you this in case you have group problems, which hopefully you will not in this class. User accounts, right. Okay, so let me go through this one part because it is important. All right, you notice over here, when I did a dash long listing, we have all this information. R stands for read, W stands for write. And then we have dashes, meaning that I don't have permission. What does it mean? Well, ignore that first one. That means something special. That's a sticky bit. Don't worry about it. RW means that the user of this file, aka, or the owner, the owner of the file, which is Quest, can read and write to it. The group can only read to it, and everyone else can only read, or read from it, I should say. So if you want to, do I give you an example? Right, here we go. So the first set of 3 letters for what the owner have permission to do, the R in the first position means you're permitted to read, a W in the second means you're allowed to write. This includes the ability to delete a file. So to delete a file, you must be able to write to it. And X means you may execute the file. And that means to run it, not to get rid of it. A hyphen in any position means you don't have that permission. The best way to use chmod, or change modification, is with numbers. I know this seems counterintuitive, but that's how it's stored. Read equals 4, write equals 2, and execute equals 1. So 0 means no permission, 4 means read only, 5 means read and execute, 6 means read and write, and 7 is full permission. Look, I just added up the values, and that told me what it is. When you go into architecture, it'll make a lot more sense where these numbers came from. So yeah, if I do chmod 700 on etc.out, so now the owner has read, write, execute, and no one else has permissions to do anything. Okay. So let's go through a couple examples. So with chmod, you have 3 numbers. The first one is the owner. That's the 7. I didn't say that. The second one is for the group, and the last one is for world or everyone else. So 7, I'm giving myself or the owner full permission, group has no permission, and everyone else has no permission. So a couple examples: read, write, execute, read, execute on archive.sh. Chmod does 754, read, write, execute, that's 7. 5 is read, execute, and then 4 is read only, so they simply drop the execute. Read, write, let's see, read, and top secret. Chmod does 600, so now only the owner can read and write to it, and no one else can read from it, which is probably what you want for a top secret document. By the way, just FYI, this is the first or one of the lines of defense in securing files. There are plenty more than this, but this is a very common start. Publicity, there we go. Read, write for the owner and nothing else. Well, we want everyone to at least be able to read it. So we'll give the owner read, write. The group will read, write, and everyone else can just read it. We don't want someone to, deface our public HTML file, and that's what it becomes afterwards. All right. Any questions on this part so far? I'm telling you this because you're going to at some point have permission problems, and this is what's going on. It says you can't write to it, you can't read it. You can fix this by chmodding it or change ownership of it, or any of those commands. Passwords, etc password, the database file for all users is just like here. Okay, I showed you that, where X is the password. These numbers are your actual user ID and group ID. So 74 maps to the SSHD user, and 74 in this case actually maps to the SSHD group as well. If you have more than one group, it will actually list different ones. Very important to become root. Temporarily change your identity with su, or you can do sudo su. You'll probably be doing sudo su a lot. Why do you become root? Because Linux doesn't care about permissions if you're root. It just allows you to do it. So when you become root, you can do whatever you want, and Linux is not going to ask you. It's just going to do it for you. Wow, we got through that fairly quickly. Huh. All right. I'm going to write a command. You're going to tell me what it does.
Gives everyone access to everything.
Yes. That's basically it. Give everyone access. What it's literally doing is the permissions is going to give rewrite execute for the owner group and everyone else. What's it going to do it on everything in the current directory? Oh, we're going to go through it recursively and do it for all the directories belowhand. Is this a good idea? It's a bad idea. Is it going to get rid of your permission problems? All right. I'm only telling you this because I don't want you to spend your hours trying to fix permission problems. This is about data structures, not system administration. So this is the nuclear option. Try not to do this, but if you have to, if you do it, a little piece of you should die. But then you go on in life and actually complete your assignment. I'm not going to execute this command. But here's another command. Hey, this is part of your homework. Oh, I didn't tell you what F means. F means force it, don't ask me any questions. Why are you shaking your head?
That deletes everything.
Yeah.
Or it tries to.
It tries to delete everything. Luckily, I'm user right now, so it can't delete everything because I'm not root. But yeah, that'd be really bad if I hit the enter key right now. None of y'all run up here. All right, there we go. Very good. Because remember, RM does not ask you with the F. It won't ask you, and there's no recycle bin. All right. Any questions over what I just went through today? Nothing? All right. Yes, it's graded. We'll follow the instructions for the lab, and I'll go over it in a